All right, everyone, welcome back. So we're going to be talking about Chapter 8 next, which is going to be Bash Scripting Essentials. So in the last chapter, we learned about basic vocabulary on the command line. Today, we're going to learn how to take those sentences, paragraphs, and stories and continue building upon them. We're going to be moving from just typing commands to building Bash scripts. Now, these Bash scripts are what's going to automate the work for us. So what is a Bash script? It's nothing magical. A Bash script is just a plain text file that contains the same exact commands that we learned in the last chapter, but instead of typing them one by one, we're going to write them down into a file and then execute them in order from top to bottom. It's how you save a recipe of commands to use over and over again. When you create a script for the first time, you're going to have a line at the top, and it should always have, well, bash, bin bash at the top. This is called the shebang. It acts as an instruction label at the top of the package, and it tells the computer operating system, hey, the commands in this file are written as a bash language. Please use the bash program to read and execute them. This is going to ensure that our script runs correctly no matter what, unless you mistype the commands. Now, remember in the last chapter, we talked about file permissions with chmod. Now, change mode is a great command. This is the single most common reason why we'll use it, and it's going to be, well, we're going to create a new script. It's a simple text file. Now, the computer doesn't know that this is a program now that we want to run, so we have to give it execute permission. By running chmod u plus x of myscript.sh, it will say, hey, it'll flip the on switch on the operating system, say, hey, this is a script and you are allowed to run it. Now, once the script is executable, you need to tell this shell how to run it. And we do this by running the / command. Now, the / is important. It's a security feature that tells the shell, I want you to run the script with this name that is located right here in my current working directory. Without it, Bash won't find the script. Now, static scripts do the same thing. Are useful, but scripts that are truly powerful come with changing information. And this is when we're going to bring in our variables. Now, we've learned about variables in C++ and a little bit with Python. There's nothing different with Bash. We're still going to use the variable as a small labeled box where we can temporarily store a piece of information, like a username, a file name, or even a number. Now, this slide shows us one of the most important common syntax rules that trips up beginners. Okay? To put a value into a variable, you need to use the equal sign. But for Bash, there must not be any spaces around it. So it has to be file_count equals 10. To get the value out of the variable, we would use the $sign in front of it. Okay? This just ensures that we get the right key. Now, quoting variables. This is the single best habit that you can build as a new scripter. Whenever you get to use a variable, get in the habit of wrapping it in quotations, like echo my name. Why? Because inside the variable has spaces like my space important space file.txt. The quotes ensure that the shell treats them as a single item. This habit will save you hours of debugging. Now, you may want to capture the output of a command. This is a game changer, and it's called command substitution. It lets you run the command and capture it and the output directly into a variable. The syntax is $, followed by parentheses, like in this example. So in this example, we're going to run date command to get the current date. Now we're going to save it as a string of text into today's date. This is perfect for creating dynamically named backup files like backup-2025-09-09.zip. Okay. Normally, commands print their output to the screen. But in a script, you often don't want to do that. You want to save it as an output. Maybe you want to send it to another command for more processing. The tools for this are called pipes and redirection. Now, they give us control over our script's data. And we've used redirection in the other languages, and we can do it again here in Bash. So redirection lets our script read from one command and writes it to another, and great for files. This is something we use for our log files quite often. Now, there are different symbols, right? The single symbol is output to a file overwriting its contents. Be careful because it will overwrite anything that's in that file. Now, a double quote is safer for things like logs because it will help us append to the end of the file. And then the less than symbol does the opposite. It feeds the contents of a file into a command as input. So there are multiple ways of using redirection with Bash. Now, pipes are one of the most elegant and most powerful features of command line. The pipe symbol shown here lets you create an assembly line for your data. It takes the output from the command from the left and immediately feeds it as an input to the command on the right. For example, if we do an ls-l here and we pipe it into grep.txt, basically what we're saying is get a list of all the files within the directory and take that entire list and send it to grep. Now only show me the things that end and start our .txt. Once we do that, now we can only get the information we want to filter for. Now we get to really get into, well, the exciting part. We can actually start writing commands, but we need to add some logic to our commands. We can turn our programs into making decisions. Now we've done this in other languages before, but we're going to do it again here. And what we're going to start with, of course, is going to be the if condition, because we want to make sure that, hey, is a condition met? And if so, what are we going to do? So in Bash, the if statement works on a basic simple idea, success or failure. Every command either succeeds with a true or fails with a false. Okay? If the statement of the command is true, then the then code is then ran. Okay? Now, we do put their code in brackets with Bash, and this is the syntax. And for instance, we can use a test command to say, like, hey, let's perform a common test, and if it does exist, then it does the text in the future part. So let's look at the data structure. It's easier to see than just talk about. The if line in the test condition is here. If it's true, the code after then is executed. We can also have additional tests by using elif, which is a shorthand for else if. And then we can also still put the else statement at the end to like a catch everything else. So here's an example of, does the file exist? If it does, we're going to echo file exists. If it doesn't, then it will try to test again. Is the file a directory? If it's so, it will print out a directory. Or if it doesn't exist, or if neither of these exist, it will say the file does not exist. And you'll notice that we'll terminate it by using the fi command, which is just if spelled backwards. The for loop is still there. We can use loops for automation. Our for loop is perfect for when you want to take a list of items and do the same thing to each one. Like for file in list of all the text files, do something to them. And it's a very powerful pattern. It means that find every file in the current directory that ends in .txt. Yes. And for each one you do, run this block of code. And each time you run the block of code, it will put the name of the current file in the file variable so that we can work with it. So the $file was a variable and we can utilize that. The while loop still exists as well, just like with our other languages. A while loop is built a little bit differently. It doesn't work on a list of items. Instead, it just runs as long as the condition is true. So it checks if the condition, runs the code, and then goes back and checks the condition again. Now, the great thing about this is it can run until something changes, like wait for a file to appear, or do a counter or something like that. So for instance, this one says, hey, count, as long as count is less than or equal to 5, echo count. And then it adds 1 to count and goes around again. So this is going to loop 5 times because our count initially started at 1. Now the echo command, you see me use it so many times and I haven't talked about it, so let's talk about it real quick. The echo command is your script's voice. It's how your script communicates with you. It's like print in Python. It's just like print in C++. You'll use it to print status messages to the screen. Okay? It's also your number one way of debugging. So if something's not quite working or anything like that, you can echo it to the screen and see, hey, is it exactly what I thought it was supposed to be? The other useful command would be grep. You'll see grep used in scripts everywhere. It's a filtering command that searches for lines of text that match a pattern. You can use it quickly to find errors in a massive log, or combine it with pipe to see if specific program is running. It's an essential tool for pulling a needle out of a haystack of text, okay? Grep is one of those that you just have to practice a bit to get used to, but it's one of those great ones that instead of processing 10,000 lines of a log file, maybe we just grep for what we're looking for. Because the grep searches inside of files, find searches for files. It's a powerful search engine for your file system, and you can write a script to say find and locate files that are older than maybe 30 days in the downloads folder and then delete them. It's core in many like file and cleanup scripts. You'll find that all the time. So let's wrap this up a bit. You've seen the fundamental building blocks of bash scripts. We've moved from being able to just use command line in the user interface to now being a script author. And now we can take all of the commands that we've learned, start bringing them together to build scripts. And we'll do that in today's lab, okay? And so you have the toolkit to build your own simple automations. And with some more practice, we'll become IT professionals in scripting and automation. I'll see you for the next chapter.